Hello and welcome to March's CRC. This month we're going to talk about photoperiodism. We're going to talk about photoperiodism in other plants. We're going to talk about research that's happening right now at our facility, and we're going to talk about what we want to do in the future. I think this is something that all of you guys find important, but I hope I can just push at helping you understand what a tool it is when you truly understand your varieties and what the critical photo period is. So let's get into it. I know you know this, but let's say it again. Short day plants are not a new thing. There are hundreds and thousands, probably millions of square footage of greenhouse area all over the world that's been growing mums and poinsettias and et cetera, et cetera, et cetera, very successfully with high technicality, with breeders letting the growers know what sort of critical photo period there is, and these growers being able to do a good job because of that information the breeders bring with those new genetics, new plants. So, if you're new, please go back to some of our old videos. We have some really great presentations on photoperiodism, on DLI. Make sure to watch those. But for those who are new and need a little refresher, photoperiodism, it is a physiological response for many plant species that dictate whether the plant is flowering or vegetative. It's dictated by the amount of darkness the plant receives. And if we're talking photoperiodism in general, there's long day, there's short day, there's day neutral, there's obligate, there's lots of different types. But what we will focus on, of course, is the short day plant. And so apologize for the rough pixelization here, but this is just a great tool to illustrate. You have your critical photo period, 24 hours. If you achieve light over that critical photo period, your plant stays vegetative. If you're under that critical photo period, your plant flowers. It's not just as cut and dry as that, though. You can extend, I'm hoping you're seeing my arrow, you can extend your light, you can extend your morning, you can extend your nighttime, and you can even do night interruption lighting. So this is flashing within that nighttime period if you're looking to keep your plant vegetative. Now, there's lots of methods and techniques to do this. I've seen everything from booms that are meant for watering plants that hold lights that, once, twice a night, it shines over the plants, keeps them awake. A lot of people will do simply a long period of night interruption, usually from about 10 to 2. Different techniques, they all work, they work great, but a lot of it is dictated around what your setup is and what makes the most sense to control the photoperiodism of what you're growing. And I want to say it again. If you have this knowledge, it makes you powerful. Knowledge brings power. And you may say, well, we've already got blackout cloth, so it doesn't matter. We're always going to give them 12-12. That's fine, but there's more to it than just simply keeping the plant awake or not. Multiple cycles you can hit, lots you can do. And so in this talk, we'll go through some of those things to do, some of the things research is showing us to not do or to do, and maybe help you realize some of the things that are having effect on your greenhouse that maybe you don't see or even think about quite yet. Now, on the bottom right, we have the flower initiation time, that critical photo period for my hemp varieties. And I just want to show this because of the difference within varieties. All cannabis, all type 3, all, very similar in vegetative looking, different in flowering, but what it takes to have this plant flower or not is due to the critical flowering period. So we've got everything from 13 hours, 55 minutes, all the way to the really funky ones that I have termed semi-auto, because they have 18 hours. And so a large range of what makes these plants tick. And as you grow, something that I hope and that I theorize, within the next 10 years is when you're growing these plants as a business, as highly technical, you will have this data for every plant you have. You will group cultivars according to that flowering period, that critical flowering period, where you can maximize that plant. Time is money, money is power, knowledge is power. All right, let's get into some details. All right, so this is going back to Mike Alden's work. Sorry, I thought I had your name on there, but this is Mike's work from Clemson. And this is looking at 3 of my different varieties. OG, which the way this one performs, I would say is close to 80% of other cannabis varieties. Sunset has a very late flowering photo period. That's why it's called Sunset, because it's later. And then Luck is pretty similar to OG. So you may say, all right, cool, I got blackout cloth, I can do what I want. I give all of my plants 12 hours. Okay, well, let's look across these varieties. This is 12 hours with OG. It's flowering, it's finished. This plant was given 14 hours. Well, if you grew OG and you thought, all right, well, I'm going to tack on 2 hours because it's not that much, and I want to give the plant more light and total, more DLI by having an extra 2 hours. Well, if you do that with this plant without understanding ahead of time, you're going to have a lot of waste because the plant's going to still be vegetative. All right, if we move to Sunset, if you're flowering this at 12 hours, well, it's not going to flower at all. And then with Luck, it flowers, but when you zoom in, and please go back and make sure to watch Mike's presentations, but if you look at these flowers closely, this is a poorly formed flower, whereas the 10-hour, it's great. So imagine the loss either that you're having with your current varieties or simply the varieties that maybe customers would love, but because you're giving them that traditional 12 hours, it's one you threw away because it doesn't fit into your one-size-fits-all scheme. So, from this, I would encourage you, set up your own trials, really dig down and group your varieties where you can maximize that time. Of course, I encourage you to do it yourself, but if you want the CRC to do it, we are happy to do it too. We're able to run all types of cannabis, get that critical photo period, document cannabinoid growth throughout that life cycle, and really give you, a catalog, a grow guide to say, all right, well, varieties 1 through 3 flower at 12 hours. Varieties 4 through 5 flower at 14 hours. This is power. It really is. All right, so first I'm going to go over a journal that is by Dr. Ming and Runkle, and this is based off ornamentals, but relevant, and it's based off of green light and how green light can interrupt the flowering cycle. Now you might ask, why are you looking at green light only? And the reason for this is because we're right now doing a study specifically with green light. And I know you all have at least seen, if not have, rooms where the visual lighting is green light, because cannabis theory is green light does not mess with the photo period. So I wanted to see, well, let's look at other plants. Let's see what it does. Let's dig through the journals. So in this study, They, of course, looked at long day and short day plants. Their short day plants were mums and marigolds. They provided a 9-hour short day. This is standard for these crops. And then there was a 7-hour extension of light at 0 to 13 and 25 micromoles per second per meter squared. In the study, they make it very clear, even with their own hypothesis, that green light has been showing very inconsistent results through the literature. And their theory is that also looking at these varieties with specifically green light, that there'll be inconsistencies. So it's an extremely interesting study. Maybe gets a little deeper than you care to know, but if you do, it really goes into helping understand how green light is perceived by the plant and what those pigments are that take it up. It gets into some pretty cool things where it shows if you apply a certain amount of blue light, a certain amount of green light, they'll actually cancel each other out. I don't think it's not necessarily relevant for a commercial level, but dig as deep as you would like. All right, here's some of the more important results. So here I only pulled the data from short days. Time to flower. All right, we're going here from 0 to 25 micromoles meter squared per second. And you really see the most aggressive increase really under that 5 micromole intensity. So we're taking our time to flower from under 40 days to varieties or even. So as we're looking at this data, I want you to think about your facility, what light might be sneaking through, whether it's green or white, cars, whatever. And you might think, it's under 5 micromoles. It's not that much. It's really not going to do anything. Much of the time, that's right. But let's look at the data here with chrysanthemums specifically, because it seems like marigold doesn't have much effect by low amounts of light interruption. But let's look at chrysanthemum jolly red. All right, if there's no daylight extension by low intensity, then your plant will finish in about 40 days. But just by the interruption of, I don't know, we'll say 3 micromoles per meter squared per second, you are adding an additional, what is that, 40, 20, you're adding an additional 30 to 40 days on your crop just by this little bitty amount of light that you might not think is a big deal. Same with the different varieties. So you've got lost time because you're taking too long to finish flowering. So think about those crops that are 10, 11 weeks. Is it because your DLI, your hours of light is too long? Is it because there's some sort of light interruption that's causing plants not to finish as far? It's possible. Leaf number, not quite as important, but also good to see, not huge amounts of differences. And then main stem length. So if we're starting here at no interruption, you've got a plant that is 11, 12 centimeters, but just by having 2, 3 micromoles of light, you're looking at making this a much taller plant, which in some cases maybe it's good, in some cases it's bad. So it depends on what your desire is. But knowing this with your cultivars, that's where you're powerful. All right, so we'll get to the study we're doing right now. Huge shout out to Catchmaster. They do a lot of things with insects. They have sticky cards, sticky sheets, all sorts for many industries. Been in business a long time, great group of people to work with. But their thought is, we're an insect attractant bait company. What about all this rumor about green light does not affect photoperiod? Well, I can raise my hand and right here say that the industry idea of green light not affecting is absolutely wrong. Raise your hand if you've broke photoperiod with green light. Me. So when I first started at Outco, Southern California, the place was already built. It's already been in existence for months. Cycles already under their belt, so obviously 6 months or more. There was a room with this isn't the actual picture from there, but it's a good example. Very bright green light. So I'll walk in and I say, this doesn't look quite right. I thought we were on short days and they wanted to work during the dark where it's not as hard on their eyes, things I get. But because they had produced some successful crops, I thought, I got a lot of other things to worry about. This place is already constructed, like, keep doing what you're doing. Well, a little bit of time goes by and it messed them up. It definitely messed them up. So I can say with full confidence that that theory in general is not right. So with Catchmaster, their thought is, if we're drawing in insects with light, how do we confidently go into these grows and not ruin people's crop? So let me have at it. Let's figure this out together. Okay, so in our experiment, we did a very short 2-week veg. Today, we are in actually day 18 of short days, so they're pretty early on. The green lights are on for 12 hours, so we've got 12 hours on, regular light schedule, and then 12 hours on with the green light. It's a range from 0.9 to 1.35. And I did it at this much smaller intervals because we did have some previous research that showed you're really only seeing those effects under 12 micromoles or so. We did this, of course, with our type 3 variety Sunset. This is ultimately what it looked like. Light at one end, obviously different lengths, distance that these photons have to travel, give different intensities to these individual plants. So closest, you would expect to have the highest amount of light intensity and for the plants to stay vegetative. So again, keep in mind, this is at day 18 after flip of short day. Imagine the light is here on the left side, and so makes sense. The ones that are closest to this light that receive the highest amount of intensity are still completely vegetative. Whereas on the far right and in scale, as we decrease in intensity, we have more flowers. So again, we will present this at the end of this experiment too, but we had such cool results, I wanted to go ahead and show you. All right, so this is my favorite slide of the day. And as you would expect, closer you are to the light, higher light intensity, plants are staying vegetative. This is a problem. As you go on down, the second one would represent about 1 micromole. And though much slower, it is creating stigma and on its way to flowering. As we creep on further away from the light, lower light intensity, we're seeing not only more stigmas in general, but more trichomes on the leaves and a faster flower formation. So with this data, with science, with tools to be smart growers, I can say confidently to Catchmaster, with this light fixture, with this specific spectrum of green, as long as you are staying, to be safe, to have some buffer, as long as you're staying under 0.5 micromoles away from any plant, you are safe. You are not interrupting flowering. Okay, let's dig into the data. So please keep in mind, this is at day 18 after flip to short days. So we're very early on, but I will refresh you once we get past all our full flower. I wanted to do this because we're already seeing really significant, even with just pictures, seeing the differences between very low light intensities. So here we're looking at plant height. We're going from 0, which would be full darkness, to 1.4 ppfd. Now, opposite to the last slide, this would represent the plants right closest to the light, and it makes sense. The ones closest to the light are staying vegetative, and they're not doing what I call the 2-week stretch right at the beginning of flower. They're staying short. But as we come up, as we get further from that light, what you're seeing is a stretch. But what is actually kind of interesting to see is this decrease here at the end where the plants are actually shorter. So theory, all theory, but is there a case where if you were to provide a lower sum of DLI, of light intensity to these plants, there would be less stretch, even just there in the first couple of weeks? Theory, we'll figure it out eventually. Next, we're just looking at branching. And so as expected, the higher you are in ppfd, the closer you are to the light, the plants are branching, the plants are vegetative. All right, so it was a short but hopefully sweet month for data for cannabis science. But I'm going to leave you some homework, and we'll go over it next month. Look at these 2 papers, 2 new papers, couldn't be more relevant for flowering, for understanding photoperiod, to understanding yield versus cannabinoid content, and how you can maximize your cultivars. Read these papers, and next month I will go through them. I'll summarize the findings, and hopefully you can start to apply these practices, apply this education, the power, the tools to grow your plants, grow them fast, grow them with quality, grow them with speed, grow them with knowledge, and make money. Thank you, and I'll talk to you next month.